Hi everyone, I'm Jonathan Gorlin from the HyperFlex product management team. Today we're going to talk about HyperFlex. You've heard a lot about this HyperFlex Anywhere, so we're going to do a couple things in the agenda today. We're going to start out real quick and just talk about a couple of market trends, and then we're going to dive deep into the HyperFlex platform itself. We're going to cover HyperFlex 3.5, which is a release that is out and shipping today. We've had a lot of innovation over the last few months, bringing our 3.0 and 3.5 releases out, so we want to make sure everyone's up to speed on that. And then we'll dive into this HyperFlex Anywhere, what we're bringing with our new data platform, version 4.0. And then there's also a special surprise here at the end. We're going to talk about some of the innovation that we're doing cross-domain to bring a Cisco branch-in-a-box to reality. Let's go ahead and get started. Just a quick overview of kind of what we've been saying throughout this series is really the fact that it's not just about core, cloud, or edge. It's really about all three of these working together. And if you look at the trends, when it comes to the core, IT now is spending more money now more than ever just keeping the lights on, just running the business. So it's still a strategic initiative for IT to continue to reduce cost and complexity at the core. At the same time, of course, we know cloud is pervasive, and we also know now that cloud is more than one provider. You have multiple cloud providers. And what we're also seeing is by the year 2020, we're expecting 50% of enterprises will have some kind of mission-critical application running in the cloud. So this is important now more than ever. And then finally, at the edge, what's really interesting is within 3 years, we're going to see 50% of enterprise-generated data is actually going to be generated outside of the data center. And not just generated, but also processed outside of both the core and cloud as well. So if you've been following along with HyperFlex, we've kind of followed this similar journey as well. We started optimizing the core, right? Bringing in really easy hyperconvergence, being able to reduce cost, reduce complexity, really simple, simplified operations. Then we started talking about cloud story. We brought in some of the assets with our cloud center, the ability to do app mobility, placement, costing. And then we brought Kubernetes support as well. So now you can run the same workloads that you would run out in the public cloud, you can run them on-prem. And now what we're bringing with HyperFlex 4.0 is we're really going after this edge use case. So it's important that we have a platform that's pervasive across all three of these, because really at the end of the day, it's a distributed data center. We have to follow the data. That's really what IT's challenge is today. So just real quick, this is the last slide before we dive into the details, is really what are customers saying about HyperFlex out in the market? We've got a very strong customer base now. And what they're telling us is that not only are they saving cost in terms of dollars, they're also saving time in terms of how quickly can they provision, how many people does it take to manage existing environments, but they're also telling us that they're seeing speed improvements in their environment. So it's really rewarding when we hear from customers and they say that IT are getting high fives in the hallway because the report that used to take an hour to process now in HyperFlex can be done in half the time. So we're seeing great feedback from customers. Our partners as well are on board. Some of the best analysts as well. Pretty much everybody is in consensus here that HyperFlex is a leader in this space now. And we're going to continue to push forward on the innovation platform to continue to advance our leadership in this space. All right, let's dig into HyperFlex 3.5. So for those of you that have been following along, we had two really big releases this last year. Our engineering team has been really busy. Towards the beginning of 2018, we had our 3.0 release, which if you can remember was really all about running more workloads. So we provided support now for not just ESX, but also Hyper-V workloads. We added support for Kubernetes and persistent volumes as well, really extending the reach of where you can run HyperFlex, what workloads can run on top of it. We also added support for stretch clustering for metro availability, new form factors, higher scale. It was a really large release for us. But engineering was able to push even further and bring us a 3.5 release also towards the end of last year. And a couple of key themes here. So I'm just sticking to the highlights. There are a lot of details underneath as well that I won't have time to talk about. The first is a HyperFlex acceleration engine, which is really us bringing to market this co-innovation of hardware and software by bringing hardware offload to a cluster. Now, as you're scratching your head, I'm going to dig into that one a little bit deeper on the next slide. So just hold those thoughts as we get into the details. Some of the other areas, as I mentioned, are new workloads and solutions. So we want to continue to push the envelope on what can run on HyperFlex. So we now have support for Veeam LFF appliance, which is a scale-out appliance. We've partnered with Veeam to do that. We also are in the AI/ML space now, so we've qualified all new GPUs. We also have the concept of a GPU-only node, which sort of piggybacks on top of our compute-only architecture. And we've also qualified some of the industry leaders in this space. So that's certainly a workload that we're targeting very heavily.
Are you going to cover that part in the next slides? Are you going to cover AI and ML in the next slides?
Unfortunately not, because we have so much good stuff we want to cover in 4.0.
Okay.
So not in this talk. Mm-hmm. But we can maybe at the end we can talk a little bit more on that topic.
Okay.
Yeah. And then finally, SAP HANA. We're now certified SAP HANA for production landscapes. So the key theme here is alongside some of these bigger rocks, we also have our Cisco validated designs, our CVDs that our customers love. Right? Thousands of hours have been poured into really validating solutions, enterprise applications. So that gives our customers a lot of confidence that HyperFlex can run these applications. Another big area was around upgrade. We wanted to really have a full stack upgrade in a single optimized reboot, which is really unique, being able to upgrade the firmware of the server, the hypervisor, and the HX data platform all in one optimized rolling reboot. No downtime to workloads. Right? The ability for us to apply firmware is something that we can do that's ingrained in the fact that we own the server as well. Right? So this is the hardware and the software really coming together to do things better and in a more optimized way. On the container front, so in 3.0, we launched support for persistent volumes. We also qualified here OpenShift as well. So customers now have the choice of OpenShift or the Cisco Container Platform they can run HyperFlex with. And we also brought to market the dynamic provisioning capability, which really allows you to, IT to basically provide a service to their developers where they can now consume HyperFlex as persistent volume claims inside of Kubernetes without even knowing. It's totally abstracted that this happens to be running on HyperFlex. Yeah. Security is pervasive with HyperFlex, so we've done some work to automate some STIGs for some of our customers, introduce some other features like lockdown mode in ESX, some tech support mode to turn off some external interfaces. So we're constantly working on that angle as well for some of our more sensitive customers to a security standpoint. The Citrix Cloud Services is now actually in our management plane, which is our HX Connect. We also have the ability to set up a connection, a cloud connector to the Citrix Cloud. So this makes it a lot easier if you're doing more of a VDI style deployment. That onboarding is that much more easier as the UI is now integrated, helping you onboard to Citrix Cloud. Additional scale, as we do in every release, we add more scale, being able to do larger clusters. In this instance, 3 new vectors of large form factor Hyper-V and stretch cluster. So the scale continues to grow as our customers demand it. And then finally in 3.5, the last big item is really what we've done in the networking space. So we now have support for the UCS 4th Gen VIC and FI. These are both 10/25 gig. The 4th Gen VIC is a quad port NIC, so now we can do up to 100 gig per server, right? So previously we had the 3rd Gen VIC that gave us 80 gig per server. Now we're even higher at an amazing 100 gig. We also added support for our Edge appliances. We'll talk more about Edge, the ability to do now 10 gig alongside our 1 gig deployment, depending on the existing infrastructure in the remote site. Support for multi-VIC, so we have failover against failures there, and then also third-party NIC support if you want to bring in, let's say, an Intel NIC and do SRIOV, or you have some interesting NFV use case. We now allow you to drop those cards into HyperFlex. Again, run more on HyperFlex. Okay, I know that's a lot. Question.
When you said you were doing 80 gig, how do you do 80 gig? I would understand 40, I would understand 100, I would understand 25 or 50, but 80.
Yeah, this isn't a mystical 80 gig interface you've never heard about. Basically, so it's a dual port card, the 2 fabrics, 40 gig each, and they're both simultaneously active, so we get combined 80 gig per the server. Yeah. Don't worry, we're not developing any 80 gig technology. So, okay, let me dig into that first item real quick about this HyperFlex acceleration engine. Essentially what we're doing is we're taking our expertise that we have in building hardware and we're marrying it up with our expertise in software. To say, if we're going to solve a customer problem, we don't necessarily have to be biased to solve it in hardware or in software. We want to solve it the best possible way for our customer. So what we've done is we've built this custom-built card. It's an FPGA hardware assist card that's completely optional for customers. If customers want to achieve better compression ratios, if they want to achieve better VM density, this is something that they can optionally add in. It's not a single point of failure, because all we're doing is we're offloading from the CPU complex to the hardware card. So if the hardware card were to fail, we can revert back to software. What's interesting about this is it doesn't undermine our original value proposition of HyperFlex, which is that we always have deduplication and compression are always on, always enabled, no performance impact. There's no on-off switch. Those software features continue to stay. This is more about if you want to push the compression even higher and get even better TCO, this is an optional add-in card that you can use. It's a PCIe-based card. As I mentioned, it allows us to not only have higher compression ratio by using more optimized algorithms that are more suited for hardware, but it allows us to offload the CPU so the CPU can do other things. By offloading the CPU, it also gives us increased I/O. And on the next slide, I'll show you some of the performance numbers that we're seeing with the addition of this card. So it's really a triple win here that we have. We get a performance boost by offloading the CPU, allowing us to do higher I/O. We have higher VM density because we have better compression ratio, so we have more effective capacity. And we reduce the CPU utilization, and we also lower the latency at the same time, which I'll show on the next slide. Now, the really interesting part is this is starting a journey for us. We're starting with compression and decompression to offload into this hardware assist card.
Can I interrupt you for a second?
Yes.
In the hyperconverged market so far, there was only one company which was using offloading cards.
Yes.
And I won't mention it, but we know it was acquired by another company starting with H, which has a pretty bland and an appealing logo. But anyways, what is the goal? I mean, okay, I get it. You have the offloading and all, but I'm trying to find the rationale behind that, behind putting R&D efforts, spending on building customized hardware for doing acceleration. Why don't you just put there, I don't know, higher class CPUs to do that? Because this is great, but it's a lot of money spent on building custom built, let's say, hardware acceleration cards, and it's in the end it costs you, I mean, Cisco, a lot of money to do that. And there are a lot of other companies which have different mechanisms for compression, which are using software mechanisms or other ways of writing the data and all. So what is the incentive for that? Because it goes against all of what the others are doing in the industry. Mm-hmm. Now, just to help me understand. I mean,
sure. Yeah, it's a fair question. I would say something that Cisco has unique is the fact that we already have a hardware engineering team that's building custom silicon, mm-hmm. right? So actually, the extra lift for us to be able to take an FPGA and put it on a board and put it in a HyperFlex server is actually quite a minimal lift for us, right? Well, the other interesting thing is that FPGAs are relatively cheap, right? If you look at some of the higher-end Intel bins SKUs, mm-hmm. it's very pricey, right? Especially you look at going from a 16-core CPU to a 20-some-odd core CPU. It's almost exponential increase in price as you start getting to those higher bin CPUs. So what we're trying to do for customers is to say, look, we want to optimize the total cost of the solution. Now, if we can take those CPU cycles away from the expensive Intel CPU and put it on a relatively cheap FPGA, and this FPGA is relatively cheap for us because we've already invested in the R&D in other parts of the business, then that's really a win for all of us. Mm-hmm. So that's really the way we're looking at it. It's starting with compression and decompression. But you can see some of the other features we're looking at in the future. So erasure coding, cryptographic functions for software encryption, and even hashing for our dedupe engine. These are all things that are done much better, more efficiently in hardware. And so, for example, when we look at a use case like erasure coding, if you look at all the hyperconverged vendors out there, they offer software-based erasure coding, but when you turn it on, you see a very significant performance hit. So we want to be able to come to market with a better story to say, well, if we could do erasure coding and take a very small performance hit, now that's really a true value we can bring to our customers. And having that option really opens a lot of avenues for us. So that's sort of the rationale. Now, to really dig into a little bit of some of the details of what we're seeing, so there's three main benefits, as I mentioned. The first is the top line max performance increase. So if we do a 70-30 mixed block test, what we actually see in I/O is up to an 18% increase right off the bat. So you can do 18% more I/O with the same exact hardware with this card in place. At the same time, however, you get the benefit of lower latency. right? We can do something that was more expensive and taxing on the CPU complex. We can do this in a much more optimized way in the hardware. We can lower latency on average by 14%. And then the higher compression really allows us to run more optimized compression algorithms that we've seen in our testing. And our engineering has tested this across a very wide range of data sets. We've seen up to a 30% increase in storage efficiency, which means more effective capacity, which means higher density, and you need to buy less storage for a given requirement. So overall, we're really just kind of starting this with the compression and decompression, and I think you'll hear more from us over time as we continue to optimize ways of the hardware software coming together.
Question on the performance and on the latency. Excuse my ignorance, but what kind of drives are you using currently in the HyperFlex solution? Are you using SATA drives? I mean, SATA SSDs, or are you using NVMe SSDs?
So in these performance tests, this is done on our all-flash versions of HyperFlex, which are based on, you have a choice of cache drive. It can be NVMe based or it can be SAS based. Capacity drives are SATA based drives.
Okay. I'm just trying to understand the latency gain, you know, if it's more this, if it's overall, regardless of whether you're using NVMe or you're using SATA SSD drives.
So I believe the testing has been done on for sure the capacity tier is SATA. I'm not quite sure what the caching drive has been done in this test, but I imagine the results will be very similar in both cases.
I'm just trying again to understand how relevant the hardware acceleration is, because for SATA, it can be, for SATA SSDs, it can be relevant. You can feel the, let's say, the performance increase, but if you're using NVMe drives, I mean, enterprise class NVMe drives, these should already have very low latencies. So I'm trying to understand if investing into this kind of accelerator card really justifies, you know, all of these effort of R&D and building custom-built FPGAs and all for drives which already have a very low latency.
So effectively, you're saying, are we going from 1 millisecond to 800 microseconds, or are we going from 100 microseconds to 90 microseconds, right?
Kind of.
Yeah, which doesn't matter.
Yeah, I mean, in the end, it all depends on the kind of workloads which are running on the HyperFlex
Exactly,
platform.
which is why at the end of the day, we want to give customers, this is an optional card, which is different than others that have really made it a mandatory part of their data path. This is more of an optimistic.
I got it. I wasn't aware that it is an optional card. I thought that it was mandatory. My apologies for that.
Exactly. Okay, so let's move on, because I really want to get to what's new with HyperFlex Anywhere and our 4.0 release. So it really comes down to, we're really focusing, now that we have a really great install base in our core data center, customers are telling us that they want that same ease of use. They want that same elastic scaling. They want to be able to do this at scale in their remote offices and branch offices. So 4.0 is really all about extending HyperFlex out to these remote sites and being able to do it in a way that's very scalable and manageable from a cloud management interface like Intersight, which we'll talk about. So a couple of key things here. So we're going to support 2, 3, or 4 node HyperFlex Edge clusters. So you can right-size your environment depending on what your needs are. We'll support 1 gig or 10 gig networking depending on whatever existing infrastructure you have. So there's no need to refresh your networking when you want to put HyperFlex Edge out at your remote site. Some of the key innovations that you've heard about earlier today really come into this Intersight capability, which is our cloud managed, it's our SaaS offering for compute-based management. And we'll talk a little bit more about that. And what we're doing is we're putting our witness inside of this Intersight. And this is really a game-changing technology. We'll talk about how we're solving a major pain point for our customers. At the same time, Intersight also allows us to do a massive deployment, a rollout of hyperconverged at scale very quickly. We can install these clusters remotely. A couple of other items coming in 4.0 outside of Edge, just to hit on them really quickly. So all-NVMe, we'll talk about that towards the end as to why an all-NVMe appliance is something somewhat challenging to bring to market and how we've been able to crack the code there. There's some also additional enhancements around security. So we'll have some new REST APIs for STIG, some more audit logging capability. And then on the Kubernetes front, we're bringing to market a CSI plugin, which is really the direction the industry is moving. So let's dive into each of these in more details. So we talked about HyperFlex Edge. We want to put hyperconverged at the edge. If you really think about a customer who wants to go all in, they might have 100, 1,000, even 10,000 remote sites. And we have a number of customers that talk to us that have this many distributed locations. The question is, how do you deploy at that kind of scale? without taking 10 years to do it, without having an army of people. And what you really need is a management solution that solves the problem end to end, all the way from the initial bring up to the ongoing upgrades to, at the end of the day, if I need support, how do I get it? And we really think we've cracked the code here of having a full lifecycle management through Intersight with this release. So it all starts with the install. Being able to take these hyperconverged nodes, not have to put them through a staging process, send them directly where they need to go. And the most important thing is that we have a level 1 tech, someone who doesn't necessarily know how to install ESX hypervisors and is trained up on what HyperFlex is. All they need to do is rack the server, connect the network, get it into Intersight, and then the server can be deployed remotely, lights out. And this is possible because of the fact that we have integration into the physical server itself, because again, we're not just a software solution, we're a full stack solution. This allows us to do remote deployments very rapidly. You can do this using the API, of course. So if you've got a very long list of clusters that you want to customize, you can use that to import. Or we have UI-based tools that allow us to do this very quickly.
Just a quick question on the, let's say, zero-touch deployment, yeah? I guess you need somehow internet connectivity. Is there anything else? So DHCP, I guess. Is there anything else needed? Some other parts, or that's it until it can connect to the controller, then you get the whole provisioning?
We have a couple of options.
Okay.
The easiest option is connected directly to the SaaS version. Right? If you have outbound, all you need is port 443. You can NAT outbound. That's all you need to connect up to Intersight. If you don't have that capability, you can also use a proxy, or you can also put Intersight in an appliance form factor in one of your data centers. So there are multiple ways to connect into this, this infrastructure. And you can do DHCP, you can do statically assigned. As long as the endpoint has an IP address and can talk to Intersight, we take care of everything else from that point on.
Okay.
So you don't have to run the management software in the cloud. It can be on premises.
It can be on-prem, correct.
But then I have to do the DNS entry pointed to my internal
Of course.
on-prem server.
Yeah, so when you have the appliance, instead of, typically what happens is the server actually has a known endpoint that it reaches out to phone home to. Instead, when you have the appliance, you actually point it to your endpoint, and it goes and directly claims those devices. Right? So we do have that option. Now, once the cluster is deployed, when it comes to two-node systems, of course, we can have arbitration issues, right? We can have a split brain scenario, which can lead to data inconsistency. So typically, we solve this problem with an arbiter or a witness that's typically run on a third site. We decided to do something drastically different, make it really simple for our customers. We're calling it the Invisible Cloud Witness, which means that there is nothing to configure, nothing to set up, nothing that you have to manage actively. Now, once the cluster's up and running, you have to do your ongoing management. You need centralized dashboarding, centralized alerting, the ability to drill down deep into a cluster if there's a problem to troubleshoot it. Right? We can do all of this directly from Intersight, alongside those full stack upgrades that I talked about earlier that we delivered in a prior release. We'll be able to orchestrate that across however many sites you wish in parallel. So you can upgrade a worldwide infrastructure as small or as big as you want directly from Intersight. And then finally, when you do have a problem, and inevitably you will, we have a connected TAC organization that now actually allows us to proactively pull out tech support logs. So if you have an issue, not only can we auto-generate the SR and pull the logs into the case, but when you're about to call into TAC, that TAC engineer already knows the root cause in the best case possible. We can write signatures, we can do more proactive analytics. Having this connected experience really changes how easy it is to manage these endpoints and devices. So looking a little bit more at the architecture, right, you can have different size clusters depending on what your requirements are, right? You might have larger branch offices and smaller branch offices. Reuse your existing network infrastructure, whatever it happens to be. And then you connect up into Intersight, and you also connect up into your home data center, or maybe that's cloud or a combination of both. Now, the beauty of all of this is the fact that it's the same architecture that's running in the data center as is running at the edge. Same management interface, same file system, right? The same exact characteristics that you've come to expect. And it's all managed via Intersight. So Intersight is managing your data center locations, but also your edge locations. And the edge is where it's really hard. It's hard to do distributed computing. right? If you have everything in a couple of data centers, it's relatively easy to manage. You have good connectivity, you know where everything is, people can easily access it. It's when you're out at the edge that you have this problem, and Intersight is the umbrella that brings and connects everything together.
I probably missed it. So the invisible cloud witness, does it have to run on Intersight appliance, or can it be a VM running anywhere?
So the short answer of that, and I'm going to talk more about this, the technical of how the cloud witnesses work.
Sorry.
The short answer is that it's tied directly, it's married into Intersight. And the reason is for the value of we don't want the customer to have to think and design and scale the witness, that it's such a native part of the management plane that it's not decoupled in any way. Mm-hmm. So very quickly to see kind of how this operates, we have two nodes. These are two hyperconverged nodes. They have a nice high-speed backplane, a primary and failover link. Inside each of these nodes, of course, we have a controller VM that's responsible for the data platform. And then inside of that is a DC or a device connector. That's what's actually responsible for creating that persistent WebSocket back into Intersight. This infrastructure has already existed for the last year plus since we've launched Intersight. This device connector is how we get the telemetry, the alerting, the ability to get into the management interface. All of that's been there. So what's new is we've decided to put our witness protocol on top of this existing pipeline. So simply what really happens is all Intersight does is it maintains a lock and a mapping that says for each remote cluster, do either one of my nodes have a lock, yes or no? Because really what you need is you need to have a quorum, and in order to obtain a quorum, if you have the links between the nodes fail, right, you can't have both continue to operate, you'd be in a split brain scenario. So what happens is both of them race to Intersight, they try to claim the lock, whoever wins the lock continues to operate, there's no downtime to your cluster, your workload.
So that only happens when they lose the link.
So either the link failure between them or a node failure.
Well, which looks the same.
It looks the same because it's a distributed system problem.
Yeah.
You don't know if it's the link or the node. So in both cases, you'll race to Intersight.
So the moment you lose the heartbeat with the other node, you rush and try to grab the lock on the management system. And if you succeed, you go like, hooray. And if you don't, you die.
Pretty much. Yeah, exactly right. So the beauty of all this is it's secure.
So
there's no setup. Yes.
Big question. What happens when you have a brain split scenario where you lose the link and both sides are not able to reach to the management?
And race condition also will be happening anyway.
So depending on what fails first and how it fails, you could end up in a situation where the site's down. That's entirely possible. Because really, this is a CAP system and a CP system, right? So sometimes you'll sacrifice availability to ensure that you have consistency, right? Yeah. But there are a lot of different failure scenarios you can tolerate depending on what fails and how. And this is common among.
I'm just wondering if the cloud witness with Intersight is the only mechanism, because some other, let's say, if you look at the hypervisor level, for example, now I'm not talking about the HA on the storage level, but sometimes they use some other methods to try to see, if, for example, checking if they can both access the gateway or something like that to verify.
Well, put it another way, it would be nice to have a Raspberry Pi sitting close to them so that if you lose all the external connectivity plus something happens inside, at least the Pi can tell you.
I don't know all of the intricate mechanisms, but if it's just depending on that, then it might be problematic. So
So not to say too much publicly, but we are thinking of ways where could we make it more resilient, right? But this is on par and much better than what existing architectures have offered. And by the way, this protocol is super efficient, which means we don't have a periodic heartbeat back to Intersight. The only time we ever communicate back on this channel is when there's a failure scenario. So we can tolerate very high latency and lossy WAN connections as well. That's part of the intrinsic design. Now, the important thing is to compare what I've just described with the Intersight Cloud Witness. And by the way, there's no additional cost for this. It's included in Intersight Base Edition, which means if you buy HyperFlex, you get this, right? This is not a service that we're charging more for. Compare that architecture, where it's completely seamless, to one where you have to maintain witness VMs. Not only do you have to maintain a witness VM, you have to maintain the infrastructure that it runs on. You have to maintain the third site, right?
Oh, it's called Amazon.
Could be. Someone has to pay that AWS bill, right? So additional CapEx and OpEx here, and it can really be as bad as in some hyperconverged systems, one remote cluster, one witness. 2,000 sites, I need 2,000 VMs. That's the worst case. In a lot of cases, you can do a little bit more. you still have to manage these VMs. Who's going to security patch these VMs? Who's going to back them up, right?
We'll have to talk offline about who's doing that one-to-one pairing, because that is very dumb, but I really love to hear about that.
Let's talk. Yeah,
Absolutely.
absolutely.
But as you said, the Intersight can run either on the cloud, or we can have our own on-premises version.
Exactly.
Okay.
Yep, exactly.
And just one question for resiliency. Your customers can do just one, or do you recommend multiple ones? Or so you have only one. I go for on-prem, yeah? For example, I have multiple data centers. You recommend that one is enough, or should I deploy two or so just for redundancy?
You probably want to have a Intersight cluster, right, for HA. That's one of the nice things about doing it in SaaS is we take care of that for you. In this scenario, the customer has to figure out what happens to this witness VM if my server fails. Do I need HA? Do I need to DR it? What do I have to do? Right? So that's why SaaS is our preferred deployment model. We just, we do all the hard engineering work for you. But if you are going to do it on-prem, you do have options to have more of a clustered Intersight management plane so that you don't have single points of failure.
Yeah, where I'm always concerned is if it is only in one physical location, yeah? So if you have physical diversity, you can cover some maybe power outages or things like that, yeah.
Yeah. So both of those options are available depending on how you want to design it.
Okay.
So at the end of the day, this is really powerful. This is groundbreaking innovation. We wanted to take the traditional model, turn it upside down, do something unique for our customers, make it really simple to deploy at scale. Let me move forward with some of the other items coming in this release as well. So we want to talk about all-NVMe. Right? NVMe is a great new protocol, and it brings with it some nice I/O characteristics, higher I/O, lower latency at a drive level. The question is, how do we architect that into a system to be able to take advantage of it, right? Because it's not just enough to have better media. You need to have all of the underlying framework to be able to support it. The first thing you need is a good server that's architected for NVMe. Cisco designs these servers. We figured out the best way to do PCIe lane layout, make sure we don't have these extra hops and PCIe switches in the way, right? We have to really make sure we have the right platform to start with, and Cisco has that down. We've had that for almost a decade now. The other thing you need is, as you're getting better performance at the drive level, all of a sudden you're going to shift your bottleneck to some other place in the system. And no matter what hyperconverged system you're using, you always need to replicate across the network. So who better to have an all-NVMe appliance than the hyperconverged solution that has the network baked in? The low latency fabric, we've designed it. We have QoS. We have all of this figured out. And we've got 40 gig fabrics, and now we have 100 gig to the node. So the network's not going to be a problem for us. The other key ingredient that you need for all-NVMe is RAS features: reliability, availability, and serviceability. Which means today enterprises are very used to the fact that if a drive fails, let me just pull it out and hot swap in another drive. I don't think anybody would want to put into production a system in which you cannot replace drives without having to take an outage, right? This is kind of something that we've become very accustomed to. So this is a hard problem to solve with NVMe. The other thing we have to solve is, as we start processing more I/O through the same node, all of a sudden the requirements for higher endurance cache goes up as well. This is where Intel Optane drives with 3D XPoint gives us much better endurance than what we've had before. So all these components and pieces are starting to come together to really give us a good all-NVMe system. And then the final piece is the software stack itself, the HyperFlex data platform. This is our own custom log structured file system that we've designed from the beginning. And we're already seeing significant performance improvements, and we have full control over that stack to be able to continue to tune it and refine it over time. So let's just talk really quick about why this RAS is such an important thing, right? So on the left, this is really what a traditional architecture would look like. We have the storage controller, and we've kind of taken for granted the fact that this takes care of all of the hot plug, surprise removal, LED management, all that stuff has been done for us. Now, obviously, in the new picture where we're connected directly to the PCIe bus, if we pull out a drive unexpectedly, the kernel's going to panic and we're going to be in a lot of trouble, right? The host operating system is not going to like that. So what we need to be able to solve this is a new technology from Intel called VMD that adds this abstraction layer in there that actually allows us to do these operations that we've become accustomed to. That takes a lot of work. You have to partner closely with Intel to develop this in the BIOS, which we've done. And you have to put the right driver in our controller VM so that this all operates together. And then you need to test the heck out of it to make sure that there are no issues. And that's exactly what we've done by partnering with Intel to be able to bring the VMD technology to the forefront. So at the end of the day, all these pieces that I've been talking about come together to really build the industry's first all-NVMe appliance form factor that's actually usable, something you can put into production. So it's based on the 220 M5SN chassis that's optimized for all NVMe. We've got the integrated fabric. We have the VMD support as well. This is integrated with UCS Manager, so all of the management and alerting that you're used to getting exists here in this ecosystem as well. And then at the end of the day, we're seeing up to a 50% IOPS increase right out the gate. And we know, and our engineering has been doing some experimenting and tuning of the file system to know that we have a lot more room that we can continue to refine the file system for NVMe. And it'll be delivered as a simple software update. That's the beauty of having a software-defined file system like we have. So what does this mean at the end of the day for a customer? Again, run the same hardware, more density. You can run more mission-critical workloads. Right? So we're pretty excited to be really the first to bring an appliance version of all NVMe that has all of the necessary prerequisites to operationalize it.
Apologize for yet again asking a stupid question, but that 40 gig is still bothering me. Everyone is claiming how everyone is going to 25 and maybe 50 gig because you need fewer lanes, lower power, yada, yada, yada. And you're still at 410 gig lanes for 40 gig.
So this slide is somewhat outdated, actually. As I mentioned in the previous slide, we have now the 4th gen VIC as well. So you have your choice, depending on what kind of fabric you want. You can run this on 4x25 ports if you want. You can run it by 2x40. So we'll have all the options available from a networking perspective here as well.
Thank you.
I should update that, thanks.
My question maybe before we move to data protection is, what use cases are you seeing for this new HyperFlex appliance with NVMe? What applications are you planning to run on, or what customers are planning to use that for?
Yeah, it's a fair question. I would say that our HyperFlex all-flash today without all NVMe can run, ERP systems. It can run SQL, Oracle, right? We've got a lot of customers that have testified to running their business on HyperFlex. I think it's more about optimizing and doing more, right? Higher density. So I don't necessarily think it will unlock necessarily more applications unless they're at the very high end of the spectrum. But it also gives customers investment protection. So they don't necessarily want to invest in something. They don't want to buy maybe SATA SSD. If they're going to buy this and depreciate over 5 years, they want to buy, because the price delta between SATA NVMe SATA NAND and NVMe NAND is very narrow, right? And it's starting to narrow even more. So it's again, it comes down to what customers are asking for, and they're telling us.
Yeah, the reason why I'm asking is that you reach a certain point where a distributed file system, which has some kind of activities going on over the network, at some point it just cannot match with the NVMe low latencies. So I'm just trying to find here what is the sweet spot, or what is the cut point where you need to consider between going to a dedicated storage solution over a hyperconverged solution. I mean, obviously some very high-end use cases with ultra-low latency will probably drive the change there, but I'm trying to see how you position that.
But Max, to look at it from the other side, either you have on-box storage, in which case you get the native NVMe latency, or you have the storage which is somewhere else, and then you have one network hop anyway. So does it matter that much whether this one hop is HCI or whether this one hop is NVMe over Fabric?
I'm just thinking I'm thinking about just the way it is connected on the back end. If it's using RDMA, for example, or NVMe OF, or if it's using regular network connectivity.
So effectively, you're saying is the question of how efficient the transport is.
Yes, pretty much so. Because the NVMe drives all have the same, let's say, not all, but you expect a certain level of drive latency, but you also need to add the transport, the networking latency to that. So I'm just trying to figure out here where does it fit.
Yeah, and there are more ways that, as I said, we're going to optimize. The thing is, it really gives customers one more option in their tool belt, right? So we can start all the way on the low end from LFF, right, large form factor drives. We can go to 10K SAS. We can go to all flash with SAS-based caching, all flash with NVMe caching, and now all NVMe. So again, it's more about having a spectrum depending on what customer requirements fall to really figure this out. So let me just jump ahead. We're running out of time real quick. Data protection, we're going to do two things in 4.0. We're going to support SRM, Site Recovery Manager, for customers that are already operationalized here. We'll have an SRA adapter that will be certified by VMware, available from download on their site, from VMware site. And the cool thing is we can coexist with native DR workflows, which means if you have tier 0 and tier 1 applications and you want to pay for the SRM license, that's totally fine. And then if you want to do tier 1, tier 2, with our native DR workflows, that's okay also. Those can coexist, so it's a nice benefit. We also are going to have PowerShell-based DR runbooks. So we already have PowerShell commandlets for some of the primitives, but we're actually going to have the ability for us to set things like VM start order, actually do a planned migration and test recovery. So giving customers an option where they don't necessarily have to invest in a third-party orchestration tool if they don't want to, or if they want to go all in, they certainly can do that as well.
So that last bullet there is interesting. So effectively, you take the definition of what needs to be migrated or, well, restarted, and then you generate PowerShell scripts to do it?
Correct. Yeah.
That's cool.
Trying to make it easy, yeah, exactly. So the last thing before I get to the demo is about Kubernetes. So I'm not going to go through the evolution here in the interest of time. But as you know, in our 3.0 release, we announced our Flex Volume driver integration, which at the time was sort of the latest way to do third-party storage integration with Kubernetes. There were a couple of issues with it in terms of dependencies and requiring root file system access. And the industry has sort of moved and standardized on this CSI, the container storage interface. So in 4.0, we're going to have support for the CSI plugin for those that are doing Kubernetes. This should come as good news. And we'll continue to support Flex Volume Driver until we see the customer base start to move over and standardize on CSI. So we're very much invested in, this wasn't a one point in time release where we did Flex Volume to claim support. This is an evolution that we're continuing to invest on. Let me wrap up with our Cisco Branch-in-a-Box offering, which is something really exciting because what we're doing is we're taking our expertise across multiple domains within Cisco and we're bringing them together to form a solution that really unlocks a lot of value for our customer. And what we want to do is have a fully automated, cloud-managed branch-in-a-box. And it has everything you need from the compute and storage. It has top-of-rack switching, which could be Nexus or Catalyst, and integrate our SD-WAN portfolio to really give you not just a data center in a box, which we already do with HyperFlex. Now I want to do the whole branch in a box. And so at a very high level, what this looks like is everything will be driven through Intersight. And you'll start by filling out all the information about your cluster definition. This is a cluster profile of all my IP addresses and VLANs, things that I need to do at the remote site. We'll then generate automatically a switch configuration that you'll apply to your switches at the remote site. Once the site is online and reachable into Intersight, that's where we take over the rest of the deployment, which allows us to bring up the hypervisor, bring up the server itself, deploy the virtual routers, right? So we've got the C-Edge virtual appliance for SD-WAN connectivity. And then once that's up and they talk back into vManage, this brings up all of the WAN tunneling and the WAN fabric. And then we can deploy the rest of the cluster, bring up our VMs, and then we have cross-integration between Intersight and vManage. So let me just show you a quick demo of what this looks like. And I want to talk to it to a little bit more depth than what you've seen earlier of what this looks like. And again, we sort of start with this fictitious customer that we have, Casa Depot, which has branches in Barcelona and in London. And they have a two-phased approach. They've already deployed the cluster in Barcelona. They want to do a deployment in London, and then they want to expand to these 28 other stores. I'm getting a 2-minute warning, so hopefully we'll get through this video. Basically, what happens is in the Barcelona store, you can see we have our existing switches in that store. We've got our HyperFlex Edge nodes. This is a 2-node cluster that we happen to be doing here, managed by Intersight. We also have this invisible cloud witness that we talked about. So very simple to manage this 2-node solution. And we're going to put all our different remote apps for that store on there. We start with the dashboard. We can see that we've got our one server. This is an all-flash cluster coming in. We've got 25 TB of storage, good utilization, healthy, running the latest version. And we've got 2 WAN edge appliances coming in because we have an HA pair of 2 virtual routers so that we've got that redundancy at the remote site. Now, if we go to the service profile, we can actually clone this Barcelona store and basically copies all of the settings for us to another profile. You can do this in the UI, or you can do this via API, as I mentioned before. Everything is accessible via a public REST API. Now, typically what a customer would do is they would start with a golden image, and then they would maybe change a couple of settings. In this case, the remote site actually has a different time zone, so we're going to apply a different policy. And the policy makes sure that we have consistency across multiple environments. Right? In this case, at the application phase, so I'm assuming here that all the other settings remain the same, but obviously if IP addresses are different or VLAN tags are different, you can go in and make those changes. And then we're also going to check off to deploy SD-WAN as part of this deployment. And that's going to do all of the virtual router bring up integrated as part of a HyperFlex deployment. So we finally get to the summary here, review everything, hit submit. And then at this point, this kicks off the rest of the process of the bring up. And it's not a straightforward process. We've automated a lot of what's going on behind the scenes here. Right? So we actually bring up that physical server. We have that physical access into that low layer. It allows us to boot up the hypervisor. We then deploy the HA pair of those SD-WAN routers. This allows us to then pull down the configuration from vManage, right? Get the WAN tunnels online, get our VPN back to our main data center established. Once that's done, we can continue the rest of the process to deploy the edge cluster. This will actually bring up the HyperFlex cluster, deploy our software, create a data store on which we can now deploy our VMs at that remote site. So once you hit go, all of this is automated directly from Intersight. And then once we have that one store, that pilot store done, we can go to our next phase, which is now let's do all 28 of these, right? Do it very quickly and in parallel. And then when all is said and done, now I've got all 30 remote sites phoning home. I've got 60 of these WAN edges for SD-WAN. And I get all of my visibility in one place. And then the last thing really to show here is if I do want to dig a level deeper, I can go to my HyperFlex cluster list view. I can see each of my remote sites, see my cluster health and my SD-WAN health, along with other telemetry. But the integration here with SD-WAN means that now I can bring back in a lot of the data that SD-WAN gives me today. What does my link quality look like for each of my WAN circuits? So loss, latency, jitter. This is information that vManage has. We're bringing it in context into Intersight. And we're going to start marrying the 2 management planes together over time to unlock some very interesting use cases. So I think that's all the time I had. I just wanted to make sure that we had a chance to get through that demo. Any questions?
Just a quick one. Before you got the SD-WAN service up and running, is all the communication encrypted? That you need to do the pre-auto provisioning?
Of which component?
So if you start from scratch, yeah, you're phoning back, you apply the first profile, so let's call this the first phase before the actually deployment happens, yeah? Is this already encrypted?
It is. So the first step that I didn't call out in here is you actually have to claim your device into Intersight. And the way you do that is you log into the device, so you have to have something you know and something you have. So you have to have access and you have to have the root credentials to that device. And what you do is you'll copy that rolling claim code, kind of like an RSA token that's only good for a certain amount of time. And you go in and you claim it in Intersight. And all of this is over TLS 1.2. It's all a secure connection back home. And once it's securely claimed in your account, then you associate the profiles that I showed to the hardware. So you can build the profiles separately and then apply them once the hardware actually makes it to its final destination.
Okay, good.
So it looks like you tightly coupled SD-WAN with Intersight Edge, which is great. Is this the Viptela appliance, or is this ISR with Viptela running on it?
It's a great question. So we wanted to, kind of the future is the CSRV image with the Viptela code embedded, which is being called C-Edge. So this is the kind of the newer version of the appliance where those are merging together.
So that's what you're deploying.
Correct.
And the second question is that code bundled with the HyperFlex code? So when I install everything on the physical box, does it come bundled with all the rest, or does it have to be pulled down from somewhere? And where is it pulled down from?
So today it's pulled down dynamically In the case of SaaS, we have an object store that we pull it down from. In the future, we actually have the ability to, in manufacturing, we can actually plant some of these OVA files supporting ISO images for OS installation. We actually can do that and put it on some local server-side storage that we have. So we're not doing that currently today, but that's certainly something that we can do and then avoid the necessity to download the image, which is about 300 MB for the C Edge appliance, which is not huge. But if you have a Hyper-V image, let's say you wanted to do a re-image of a server from the cloud, that might be 5 or 6 GB. That's a much bigger proposition that we might want to optimize.
Yeah. So, but you do have the image store on Intersight Cloud, and that's automatically pulled down, yada yada.
Correct. Yep. Exactly. All right.
Just a quick one. Sorry to just to that one. If Viptella's upgrading their software to a newer version, you automatically also upgrading the Intersight one, yeah, so that everything becomes consistently available across infrastructure. Yeah?
So primary management will stay with vManage, right? We don't want to necessarily, because sometimes it's different teams that manage this kind of thing. We want to start to cross-pollinate the data is what we want to start with. Because the server guy might say, why is it misbehaving? They can see, oh, my MPLS link is kind of shaky. But we can start when we integrate them, we can say, well, let's make vManage aware of HX. Meaning, I don't want to necessarily just take something down without thinking about what's going to happen to my HyperFlex cluster. Or the inverse is also maybe more likely to say, I'm not going to start rebooting HyperFlex nodes if it's going to bring down my SD-WAN fabric. So that integration is certainly something we're going to do as well.
Okay.
So you're effectively using Intersight just to bootstrap the SD-WAN deployment process, to get the images there, to get the VMs up and running, and then they connect to the vManage, and off they go on their own.
Yeah. So the day zero problem, and then the day two API integration is what we're looking at right now. That'll extend over to.
So a little bit the same concept of 2 phases of deployment like you do with HyperFlex, yeah?
It's 2 phases under the hood, but it's all happening when you hit go, as we showed, it's all happening in sequence. So we're building a workflow dynamically that has the SD-WAN provisioning steps inserted in it at runtime.
Yeah.
That's how we're doing it.
Makes sense, yeah.
Okay. Thank you, guys.